James Webb Space Telescope has done it again. And something strange has been captured this time. In addition to upending our cosmos, it has now been grabbed by something so archaic that it appears that our cosmology has to start over more than ever. Before we do so, allow me to quickly walk you through a captivating moment that Webb has recently recorded. By now, Webb's photograph of Stephan's quintet has gained enormous popularity. The region in the Pegasus constellation, made up of 5 galaxies that form a compact galaxy group, has been spotted once more by the Super Telescope. Turbulence is being produced between the 5 galaxies of Stephan's quintet by a shockwave, moving through it at a speed of nearly 1,000,000 miles per hour. The intergalactic medium, the flimsy clouds of warm too-hot hydrogen plasma that exist in the space between galaxies, is being driven by bizarre phenomena, brought on by a collision between the galaxies of Stephan's quintet and an intruder galaxy. Astronomers get a clear glimpse of the intrusive galaxy, NGC 7318b, as it violently pushes its way into this group of galaxies at a relative speed of about 1.8 million miles per hour, according to new images acquired with the James Webb Space Telescope and the Otacoma Large Millimeter Array ALMA. With that speed, it would take less than 15 minutes to go from Earth to the Moon and back. This aggressive invasion of Stephan's quintet is causing a shockwave that is rippling across the interstellar plasma and establishing a recycling plant for warm and cold molecular hydrogen gas between the 5 galaxies. This shockwave is several times as huge as the Milky Way. However, Stephan's quintet is unique from other galactic collision sites because, unlike other collision sites, these 5 galaxies are not experiencing the tremendous star formation that results from most galactic mergers. Instead, the turbulence caused by these galactic collisions in Stephan's quintet is felt in the intergalactic medium, where there is insufficient material to cause star creation. This means that star formation is not obscuring collision-triggered turbulence, giving astronomers an unobstructed glimpse of NGC 7318b, as it swiftly fragments into Stephan's quintet. The scientists' observations enabled them to create the first ever precise depiction of how the hydrogen gas is continuously reshaped and transferred. That is very amazing, but wait until you hear about Webb's discovery of the oldest galaxy in the cosmos, which, surprise, includes the same gas that humans breathe on Earth, molecular oxygen. You are watching Call of the Cosmos. The Webb telescope is living up to its promise as a time machine. The spectacularly sensitive observatory is finding and confirming galaxies more distant, and therefore existing earlier in the universe's history, than any seen before. And now, it has confirmed extreme distances to 4 galaxies, one of which sets a record for cosmic remoteness by shining about 13.475 billion years ago. Dozens of other galaxies also have been spotted as they were just 550 million years or less after the Big Bang, meaning the light from those galaxies traveled at least 13.1 billion years before reaching the telescope. Taken together, the new observations suggest galaxies formed earlier and faster than previously thought, and astronomers around the world are a bit nervous now, because the existence of these galaxies is toying with our cosmology. For the most distant objects, like the first stars and galaxies, their visible light is stretched by the relentless expansion of the universe into longer infrared wavelengths that are invisible to human eyes and some previous space telescopes. But now, measurements that were recently impossible are suddenly easy with the jwst. Even in the very first image, released in July 2022, astronomers spotted galaxies whose light originated 13 billion years ago or more. But those distances were estimates. To measure the distances precisely, astronomers need spectra, measurements of how much light the galaxies emit across many wavelengths. Those measurements are slower and more difficult to make than pictures. Thanks to this glorious telescope, we are now getting spectra for hundreds of galaxies at once, said astronomer Emma Curtis Lake of the University of Hertfordshire in England. Among those are 4 of the earliest galaxies ever seen, some of which existed less than 400 million years after the Big Bang. The previous distance record holder existed between 13.3 billion and 13.4 billion years ago, or about 400 million years after the Big Bang. Webb confirmed the distance to that galaxy and came back with 3 more, whose light comes from as early as 325 million years after the Big Bang. That is immediately after the Big Bang in cosmic scale, and throws the cosmic dark age out the window. And not just that, these galaxies are also surprisingly pristine, chemically speaking, lacking in elements heavier than hydrogen and helium. We don't see that in the present-day universe. It could mean that not many of the galaxy's stars have died in supernova explosions that spread heavy elements around the universe, which suggests the galaxy's original stars were not extremely massive. And distant galaxies that lie behind a massive galaxy cluster called Abell 2744 are also more numerous and distant than expected. Before jwst observed the cluster, astronomers predicted it should find effectively 0 galaxies from 13.2 billion years ago. But we found 2. So something's a little bit weird, said a scientist. This could mean that galaxies form earlier and faster than thought. All these new galaxies are exciting because they could be responsible for making the universe transparent to visible light, a process astronomers call reionization. Before the first stars ignited, the universe was filled with a hot, dense soup of particles. The first stars and galaxies bathed the universe in ultraviolet light, splitting electrons off hydrogen atoms and allowing light to zip through until it reached jwst. The new data give us constraints on when this process started, ended, and which galaxies were the culprits for this process. With time, more data will be unveiled, and who knows if Webb breaks its own record and finds something beyond the Big Bang. That will just break our cosmology like a piece of glass. But hey, what is science if not constantly challenging what we know and updating our knowledge in that process? What do you guys have to say? Drop in your comments below, and don't forget to subscribe to Call of the Cosmos. Thanks for watching, and we will see you again very soon. You are watching Call of the Cosmos.